I just started it, so it's recording, and you can kind of move it however you want.
6.1.
6.1. We're learning about atoms and elements and compounds. Now, you should have probably done this in physical science. Do y'all remember that? There's a thing down here you can loosen if you want to.
That's good.
You got it?
It's good right there.
Okay. So,
Yeah, like,
an atom is made of 3 parts. Do y'all remember the parts of an atom? Of protons, neutrons, and electrons? You guys remember this from physical science?
Yeah.
Yes.
That was exciting, wasn't it?
I just took it.
Protons all have a +1 charge. Neutrons have a 0 charge. Electrons have a -1 charge. Protons and neutrons are found in the nucleus. And electrons go around, they're in the electron shell. So you got your protons and neutrons in the middle, and the electrons orbiting it. Remember that?
Yeah.
The electrons move so fast that it makes like a cloud, what we call the electron cloud. The electron is not located in any one place. It's kind of just spinning around real fast and kind of is in this cloud around the nucleus. And the spinning is so fast that it makes like a solid barrier. Have you ever had your ceiling fan spinning around real fast and you try and throw a Nerf ball, and if you get the fan going fast enough, you can't throw the Nerf ball through, it just knocks the Nerf ball across the room, and your dad goes, "What are you doing? You're going to break the fan." You're like, "I'm not going to break the fan." Y'all know what I'm talking about?
I did that to one of my friend's sunglasses.
So, that's what the electron cloud is like. The electrons are moving so fast that they make this shell, and it's like acts as a barrier. Nothing can get through it. When in actuality, the atom is mostly empty space. The atom, if you could increase the size of the atom to a real big size, if the nucleus were this big, the electron would just be like a grain of sand. And it would be way out there by the road where you turn in, going around. The atom is mostly empty space. There's a small nucleus and electrons that go around real fast and make a hard barrier. If you could stop the electrons, there wouldn't be a barrier there, and it'd just be mostly empty space. But because the electron's moving, it makes a nice, tough barrier. You want to see a Simpsons video about Homer Simpson taking a nuclear physics class?
Yeah.
Good morning and welcome to Nuclear Physics 101. I see a lot of new faces, but you know the old saying, out with the old, in with the nucleus. Now we'll begin by... Did you see that jerk? I dropped his notes! Now, if anyone would like to stay, I'm going to hold a comprehensive review session after every class.
Do we have to?
No.
Then goodbye, Kirby Butt. Goodbye.
Homer had to go back to school to learn how to run a nuclear power plant. Okay. So, here again, here's the model. Protons in the nucleus. Here's a single proton in the nucleus and electrons going around. This is a hydrogen atom. A hydrogen atom has 1 proton and 1 electron. That's all a hydrogen atom is. No neutrons. One proton and one electron. We call that hydrogen. We call any atom that has one proton hydrogen. This is what they've named each element. They've given each element a name according to how many protons it has. If it has 8 protons, we don't call it hydrogen. You know what we call it? Oxygen. Do it, Hollis. 8 protons is oxygen. Now, oxygen has 8 neutrons also, but it doesn't have to have 8 neutrons. Sometimes you can have oxygen that has 9 neutrons, or oxygen that has 10 neutrons. Let me see if you and your partner know this. Write it down if you know the word for an atom that has the same number, 2 atoms that have the same number of protons, but different numbers of neutrons. Don't try to look it up. Just see if you remember this from physical science. Same number of protons, different number of neutrons. Uh-oh, we've got an answer coming. Blue. Blue gets it right.
Oh, God.
Green. Green gets it right. Y'all remember this stuff. Good for y'all. 10 points each for a correct answer. This is second period. Y'all did learn stuff in that class, didn't you?
I just kind of flipped to the page.
You looked it up?
I already flipped to the page. And plus, I already kind of knew it, but...
Now, for an atom to be neutrally charged, it has to have the same number of electrons as protons. One proton is +1, one electron is -1. That evens the charge out. So it's an uncharged atom. So if you're oxygen, you have 8 protons, you're going to need 8 electrons. Do y'all remember electron levels from physical science?
Yes.
Hollis, you remember electron levels? The first energy level can hold 2 electrons. The second energy level, you know how many electrons it can hold?
8.
8. That's right. So, every electron energy level after the first level can hold up to 8 electrons. Can hold at least 8. And if it has 8 in its outer level, the atom is in a very stable state. Y'all remember that from last year? We call that the octet rule. Remember the octet rule? Let's see a little video footage of an atom.
Yeah.
An atom has a nucleus with positively charged protons and uncharged neutrons. Negatively charged electrons orbit the nucleus and are arranged in shells. The shell closest to the nucleus contains a maximum of 2 electrons. All others can hold 8. The number of electrons equals the number of protons, and inner electron shells must be filled before any electrons are added to shells farther from the nucleus.
Remember all that stuff from physical science? Here are all the elements. And they're all, and it shows them on page 149 in your book. And these are all the elements that exist, because again, an element is named for its number of protons. So if it's got 1 proton, it's hydrogen. It's got 2 protons, it's helium. 3 protons, it's lithium. 4, it's beryllium. And the more protons you have, the bigger the nucleus starts to get. When the nucleus gets really big, it starts falling apart. It won't stay together. So after you get to about 100 or so, 92 is about the biggest naturally existing nucleus. Bigger than that, it kind of breaks down over time. What they do in these big nuclear colliders, have you ever seen these particle accelerators? Have you ever heard of the LHC, the Large Hadron Collider that they just built? And what they do is they can smash atoms together. And you can take 2 nuclei and smash them together, and they'll stick together for a while, but then they'll fall apart. There is a word that describes a nucleus that likes to fall apart, and when it falls apart, it gives off some energy. Do you know what that word is? Write it down. if you can think of the word that talks about a nucleus that falls apart and gives off some energy. There's a word for that. We'd say that the atom is blank. You there? You gonna try it, Green?
We got it. I think.
You got something? Is a word for an atom, a nucleus that kind of falls apart on its own and gives off some energy.
God.
Let's see. Green's gonna try it. Green is correct.
Yeah.
Blue, anything? No?
Blue.
It's called radioactive. A radioactive element kind of falls apart. It's an element that's not too stable. It'll just kind of fall apart and give off some energy. We call those radioactive elements. All the biggest elements on this table, all the ones down here, are radioactive. Because the nuclei won't stay together, they fall apart. By the way, those neutrons, you know how it's protons and neutrons in the nucleus? The neutrons are like glue. The neutrons help hold the protons together. Because the protons are positively charged. They don't want to stick together. It takes a neutron to hold them together. The neutrons are like glue. Do you want to hear a song with all the elements in it?
Yeah.
It's called the Element Song.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, and terbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, chromium, lithium, beryllium, and barium. There's holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium, and lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Good.
Isn't that great?
I didn't hear him say good.
That was all of them. Do you know them all now?
No.
Did y'all study this in physical science?
We studied like 3 rows.
Did you ever hear that song?
No.
She never played the song? So here we talked about isotopes earlier. This is carbon-12. Carbon-12 has 6 protons and 6 neutrons. Carbon-13 has 6 protons and 7 neutrons. Carbon-14 has 6 protons and 8 neutrons. They have different numbers of neutrons, but they're all carbon because they all have 6 protons. We say carbon-14 is a heavier atom than carbon-12. Carbon-14 tends to be radioactive. The nucleus, it's a little too big. There's a little too many neutrons, so the nucleus will tend to fall apart. And every once in a while, a neutron will just shoot off of there, or even differently, a proton will just shoot off of there. You have some radioactive carbon-14 in your body right now. Most of the atoms that you have, and a lot of the atoms that you have in your body are carbon. And a little bit of that carbon's radioactive. So you're a little bit radioactive. Did you know that?
Yeah.
You're giving off a little energy right now. Just a little bit. Some of those carbon atoms are decaying, giving off some energy. It's not enough for you to detect, but it's there. And machines can detect it. We have some sophisticated machines that can detect that. So this is heavy carbon, and this is light carbon.
All atoms of the same element have the same number of protons, but may vary in how many neutrons they...
It's a guy talking, but there's no video. Radioactive radioactive isotopes are useful. They can be used to diagnose diseases. This is the thyroid gland. You ever heard of the thyroid gland? It sits right here in your throat. And it makes some hormones for you that control your metabolism. Now, some people have problems with their thyroid gland. And sometimes it can get cancerous or something like that. It can start growing a tumor or something. Do you know the old way the doctors had of looking at someone's thyroid gland? They would cut open your neck, and they'd pull the skin open, and they'd look at the thyroid gland. I got a better way to look at the thyroid gland. Inject somebody with radioactive iodine, an isotope of iodine that's radioactive because it's got extra neutrons. And that iodine will circulate throughout your body, but the thyroid gland collects any iodine that's floating around in your body and stores it because the thyroid gland needs iodine to make its hormones. And so if I inject you with some radioactive iodine, it'll all end up in your thyroid gland.
Does that take long?
It doesn't take too long, no. It's a few hours. And then your thyroid gland will glow. It will shoot out a bunch of radiation. Now, it's not enough radiation for you to see or to feel, but if I put you in a big machine that is specially made to look for that kind of radiation signature, you can see the thyroid gland without having to cut somebody's neck open. Wouldn't you rather do that than being cut open? So that is a diagram of the thyroid gland, and if it had a tumor on it or something, you'd be able to see that tumor without cutting somebody open. Isn't that cool? Here they've injected somebody with radioactive glucose, and it goes into their brain, and it sends out signals, and this machine is the machine that can see the radiation. We call it a PET scan, P-E-T, positron emission tomography. It means it's a machine that looks for the radiation coming out of a radioactive isotope.
The positron emission tomography, or PET scanner, allows a physician to see blood flow to an area such as the brain. The image is formed by the tracking of radioactive isotopes that are introduced into the bloodstream. Computers create an image of the body tissue, converting the energy emitted by the isotopes into a colorful map of activity. A PET scan can be used to diagnose any abnormal physiological activity.
What's the machine that they put, like, people's whole bodies in?
There's different kinds. There's one's kind of called a CAT scan that takes X-ray pictures, and one's called an MRI that does a magnetic. It uses magnets to take pictures. There's different machines. Probably a CAT scan is the one you think of. Pretty common. Okay, let's talk about chemical bonds. Did y'all study this in physical science? There's two types of bonds we're going to talk about: ionic bonds and covalent bonds.
Yes.
Y'all did those?
Yes.
It comes from sharing electrons. A covalent bond comes from sharing of electrons. And here's the way this works. I'll draw it on the board for you. Hydrogen. Hydrogen has one proton in the nucleus. You and your partner write down for me. How many electrons does hydrogen have? Write it down. How many electrons does a hydrogen atom have? A normal hydrogen atom. Not something you look up, you got to think about it. A normal hydrogen atom has one proton. How many electrons does it have? Blue, got it right. Green, you got an answer?
Yeah.
By the way, if you don't know these, you don't have to answer. Green got it right.
Oh, yeah. You can't be
The easiest question. Hydrogen has one electron. I'm going to draw it like that. Does hydrogen have a full outer electron level?
No.
How many does it want to have a full hydrogen outer electron level?
2.
It wants 2. It wants one more. Oxygen has 8 protons. 2 in its first level, how many would it have in its second level?
6.
6. We'll draw them 1, 2, 3, 4, 5, 6.
And if it has 2 more, it'd be stable.
If it had 2 more, if oxygen had 2 more electrons, it would be stable. So what happens is whenever an oxygen atom comes near a hydrogen atom, they combine with one another. They share their electrons. So this 1 that oxygen has will share with this hydrogen, and the hydrogen will get real close to the oxygen and they'll share their electrons. We call that a covalent bond. Here, and that same thing happens down here. A hydrogen gets real close to an oxygen and they share those electrons. Now this hydrogen has 2 in its outer level. This oxygen sharing with the 2 hydrogens now has 8. Everybody's stable and happy. Did y'all learn that in physical science?
Yes.
How they share electrons?
Yes.
Do y'all remember learning that? Hollis, do you remember learning that? Yeah? So we call those covalent bonds. You're not going to separate these 2 because they're stable and happy the way they're sharing. It'd be like if I was sharing a milkshake with my buddy here and neither of us was ours and we had to share the milkshake. It's going to be hard to separate us in our milkshake. You're going to say, come on, Willis, let's go. I'm going to be like, no, I want the milkshake. Is that a good example? People on the video are going to be like, what's he doing? That's great. See, they're sharing. We call that a covalent bond. One hydrogen will share with another hydrogen. Each has 1, but when they share, they have 2 now. So it's going to be hard to separate. We call that a diatomic. Y'all remember the diatomic elements? Y'all remember that from whichever group can name the most diatomic elements gets 10-point bonus.
You're on your own.
Hydrogen is one of them. And there's...
Yeah, how many are there?
There's 6 more. Don't look it up. Can you name them? Just guess off the top of your head.
We get one wrong, it's the whole thing wrong?
No, they're not. Whoever gets the most between the 2 groups.
I've never heard of
Which
this.
elements are diatomics? That means they share electrons with themselves. Hydrogen's one of them. There's 6 other ones. I'll give you 10 seconds. 3, 4, 5, 6, 7, 8, 9.
That's what every element I knew.
You got 3 of them, other than hydrogen. You got 2 of them blue, so green gets the bonus point.
Yeah.
Here's how to remember the diatomics. Phenolphthalebrine. Hydrogen, nitrogen, oxygen, fluorine, chlorine, iodine. Those are the diatomics. So you can have H2, or you can have N2, or you can have O2. Y'all never memorized phenolphthalebrine?
Nope.
I was going to name my first kid Phenolphthalebrine Willis. Look at this. This is CH4 methane. This carbon has 4 electrons in its outer level, and it shares with 4 different hydrogens to form methane, CH4. That's a gas. Y'all ever heard of methane gas? It's flammable. It's a very flammable gas. It's a big constituent of cow farts. Cow farts have a lot of methane. There's actually power plants out there that put a big bag over cows' butts and collect the cow farts, and then bring them to a burner, and it burns them and makes electricity.
Are you serious?
Serious.
How much electricity in one bag?
A lot.
Wow.
Crazy?
Well,
You don't let me look it up.
nerd.
All right. Enough about cow parts. So sharing electrons, that's covalent bond. There's another type of bond called ionic bonds. That's loaning electrons. I didn't get to it, but you'll have to read it. So you got to read 6.1, and we will continue our game next time.